concentration is the amount of substance per defined space. Greater concentration would mean that there is a big amount of substance per defined space, contra a low concentration where there is a small amount of substance per defined space. Concentrated solution will increase the reaction rate. This happens due to collisions between two particles. In order for a reaction to occur, particles must first collide, and if there's a higher concentration, then there's a higher chance for a collision to occur. You see 5 particles moving rapidly in a bigger space, and now 5 particles moving before us in a smaller space. The first collision happens much sooner in the smaller space due to a higher concentration, which means that the rate of reaction will be faster. To solve an everyday problem, such as calculating the concentration of caffeine in a cup of coffee, we use a formula. Concentration is equal to moles divided by volume, or C is equal to N divided by V. So the moles of caffeine in a cup of coffee is 0.006436 moles. This we know from using another formula previously in a previous video. So volume of average cup of coffee is 1.5 deciliters or 0.15 decimeters cubed. Now when we have the volume as well as the moles of caffeine, then we could find out the concentration by using these figures to calculate the final number. The process of making a solution thinner or weaker by adding water or another solvent to it without changing the solute. Adding the solvent results in a solution of lower concentration, in for example, saft. Concentration in pure saft is 20 moles per decimeter cubed in a volume of 0.1 decimeter cubed. Concentration with water added is 2 moles per decimeter cubed. How much water do we have to add to get this perfect concentration? Used to calculate dilution is the concentration of the first solution times the volume of the first solution is equal to the concentration of the second solution times the volume of the second solution. C1 times V1 is equal to C2 times V2, which is also the unknown in this formula. We can see that the concentration of the first solution is 20 moles per decimeter cubed and the volume of the first solution being 0.1 decimeter cubed. And then the concentration of the second solution being 2 moles per decimeter cubed. Unknown variable is the volume of the second solution. We make it the subject of the formula and then substitute the variables we know into the formula and solve for the unknown variable, which is the volume of the second solution. Is the volume of the second solution, which is both water and the pure saft. We only want to know how much water needs to be added, not water and pure saft to the solution. We then subtract 0.1 decimeter cubed, which is the saft solution, from 1 decimeter cubed, giving us 0.9 decimeter cubed, which is how much water in total needs to be added to make the perfect saft. Simply add 0.9 decimeter cubed of water to make your perfect saft. Titration is a technique where a solution of known concentration is used to determine the concentration of an unknown solution. Often the aim is to neutralize the solution and the reaction can be indicated by a color change. The formula for calculating titration is M acid times V acid is equal to M base times V base. To understand what this formula means, M acid is equal to molarity of the acid, V acid is equal to volume of the acid, M base is equal to molarity of the base, V base is equal to volume of the base. Calculate the concentration of a 25 milliliter sodium hydroxide solution of 1.25 moles. Hydrochloric acid is needed to titrate to the equivalence point. First we have 25 milliliters of sodium hydroxide. Then 35 milliliters of 1.25 moles hydrochloric acid. Now we have enough information to calculate the concentration using the general formula. First we take the 1.25 mole times 35 milliliters, which is equal to M base times 25 milliliters. M base times 25, this gives an M base of a value of 1.75. So this is how you solve a calculation like this. We noted that this formula only works when the ratio of acid and base is 1 to 1. When it's 2 to 1 or another number, it needs to be a modified version of the general formula.